What's going on, YouTube? It's your boy Tico here, coming at you live from the whiteboard. Not really live, recorded, but we are at the whiteboard here. Today we're going to be going over a problem called two-number sum that I got off of algoexpert.io. I am not getting paid by algoexpert.io. Clement, if you're watching this, awesome content. Would I like to be paid? That would be dope. That would be awesome if you would pay me to promote your material, because it is that good. Check it out. Okay, so this is a rather easy problem. I only say that because it's under the easy category on algoexpert.io. It's called two-number sum, and I'm going to read it for you here. We're going to go over it, and we're going to solve the challenge using a brute force solution, and in the next video we'll go over some optimized solutions that will improve on time complexity and then also space complexity. So, all right. So the first let's go over the prompt. Right, two-number sum. What is it about? It says write a function that takes in a non-empty array of distinct integers and an integer representing a target sum. If any two numbers in the input array sum up to the target sum, the function should return them in an array. If no two numbers sum up to the target sum, the function should return an empty array. Assume that there will be at most one pair of numbers summing up to the target sum. So I'm going to go ahead and include this in the description below the video so that you can read it. Let's go ahead and put these inputs up on the board here. Okay, so the name of our problem is two-number sum. So our sample input, hopefully that's big enough so you can see. This is the sample input that they provide for us. It's an array of distinct integers, 3, 5, -4, 8, 11, 1, -1, and last number is 6. All right, and then the second input, which they describe here as a target sum, it's going to be 10. And then the sample output, is going to be an array of -1 and 11. Okay, so if you look at that problem description underneath the video there, and kind of go over the prompt again, right? It says write a function that takes in a non-empty array, so this input here, of distinct integers, so meaning that none of those are alike, or even close to alike, and also an integer representing a target sum. So what they're doing, it says if any two numbers in the input array sum up to the target sum, the function should return them in an array. And so we see here in the sample input and output, we have these 8 numbers here, just 8 integers, right? What's the first thing you notice about them? Well, first thing I notice anyways is no floating point numbers. That was a pretty sweet move. No floating point numbers, and there are negative numbers. So negative numbers are allowed to be in the input array. Floating point numbers are not allowed in the input array. What else do we notice? We also notice that they're not in any sorted order. They're pretty all over the place, right? And then this number here also looks like it possibly can be negative. It's not negative here. Doesn't look like it can be a floating point number either. And yeah, so that's what I noticed about the sample input. Let's look at the sample output. Okay, so sample output, basically the problem says no matter what, you're going to return an array. Whether that's an empty array or an array that has the actual pair of numbers that sum up to the target sum, you're going to return an array somewhere. Now for this problem, I'm going to be using Python as the programming language of choice. And in Python we don't have these arrays, they're called lists, so we're going to be referring to lists. Sorry about that. So Alright, so we know a lot about our input, we know a lot about our output. Some other things that we need to take into consideration before we start coding, or pseudocoding if you will, is we should probably figure out what are constraints, right? The only constraint I remember from the problem, and if you look in the description below, it says that we can expect at most one pair of numbers from the given input array that sum up to the target sum. So at most, this array that's returned, it will only have one pair of numbers. And it doesn't actually say that you have to return them in any specific order. In the sample input that they provided, actually it's returned where the first index, or sorry, the 0th index number has a lower value than the first index number. So yeah, that is our understand phase that we learned at Lambda School. We go through a problem-solving framework that we're taught. It's called UPER. U-P-E-R. It's super helpful. I've used UPER to solve many problems at my house that are not coding related. I've solved issues with understanding my 2-year-old who can say some words and can't say some other words. And so the U, which is the phase we just went through, stands for understand. If you don't understand the problem, you probably shouldn't start coding, right? That's a big mistake that a lot of people make, and this is a big mistake that our instructors pointed out to us when I was going through the curriculum. Sean Chen and Brady, they're very adamant about us spending less time coding and more time thinking through the problem, trying to understand all the different edge cases, and trying to understand all the different constraints, trying to break our code after we've come up with a brute force solution, which we'll do here soon. So first step, understand. Second step, plan. Right? You may understand the problem, but it's not going to do anything for you if you don't have a plan in place on how you're going to solve that problem. And then the next step after the plan phase is going to be execute. Right? I mean, you can understand stuff, you can plan all day, but if you don't get to work, that problem's not going to get solved. Last step here, R, stands for reflect and refactor. Now, when I was going through the curriculum at Lambda School in the computer science portion, we didn't have this nifty little acronym, if you will, there, the UPER acronym, right? We had Polya's, right? George Polya was a mathematician who came up with 4 steps, right? Basically, these are based off of George Polya's problem-solving framework, which understanding the problem, planning a solution, executing the plan, and then reiterating, reflecting, refactor, what have you, right, for R. But essentially, that is what problem-solving framework the instructors at Lambda School have taught us, so that we can go beyond knowing any single tool like React or Vue or Next.js, what have you. A lot of these things and these tools that software developers and computer scientists will be using, they're going to change over time, but these principles won't. And actually, they're so universal, like I mentioned before, you can actually use them to solve other problems in your life that aren't code related. All right, so enough of the lecture. Let's go forward with the plan phase. So we did the understand. Now it's time to do the plan. So when I see this here, the sample input, my goal then is to figure out what 2 numbers in this array here add up to that number, right? So essentially what I'm trying to do is I need a variable, like, let's call the first variable x, and I need another variable y, and I need to know, does that equal 10? Does that equal my target sum? So how am I going to do that? How am I going to have access to 2 different variables on the same list? Well, good thing you asked. We can actually use a nested for loop, which I know it sounds like a ridiculous option, right? A ridiculous solution, but it's a good brute force solution, meaning it's a good first pass solution that we can just get on the board, get on the paper, and not worry about finishing the interview without a solution, right? We want to at least have a solution. And then after that, we can talk about poking holes through that solution, trying to figure out, where is it, where can it break? How can we optimize it? What's the runtime complexity? Can we improve it? What's the space complexity? Can we improve it? So, yeah, we need to get access to those two variables. We're going to go with the for loop. So let's write right here. So I'm going to write brute force there. Step one, I'm going to create a function. That, let's get rid of these to make for some more room. So create a function that takes in two parameters, and like we talked about before, or as we see in the example there, it's going to take in two parameters. The first one's going to be an array, or in Python, it's a list of distinct integers, right? So they can't be floating point numbers, they can't be, just can't be floating point numbers. They can be negative though. So, and then the second input we're going to take in, or second parameter we're going to take in, is a target sum, right? And that is going to have a data type of integer. So we're going to create a function that takes in two parameters, array / list, and an integer, and it's going to return an array or list. An array, list. So that array or list, like you said, which can be empty if there are no two numbers that pair up to make the target sum there. It can be empty, or there's going to be just one pair. One pair of numbers that add up to the target sum, right? Okay, and then second, what do we need to do next? We need to look at this, and we need to, like we talked about, we need to create a nested for loop situation. Every time I say that, it doesn't sound good, but for the brute force situation, it's okay. Okay, so we need to create outer for loop. And what is that going to give us access to? So outer for loop, I'm going to represent the outer for loop with an arrow that points down. How about that? Okay. So this outer for loop is going to iterate through each of these items in the list / array, right? So it's going to go from there to there to there to there to there to there to there into there. And as it's iterating through, we're going to have another nested for loop, right? We have another nested for loop, and I will represent that with an arrow pointing up. And so when this arrow, when the outer for loop is iterating on the number 3, or the first item in the list, the second for loop, or the inner for loop, is going to iterate through every other number for that number. So we have access to both of those numbers in the same list without having to create another list or array, right? So this one's going to go here, and that's going to go here, 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 and there, and so forth. All right? So what do we need to do? We have these two for loops, and the whole reason behind the two for loops is so that we can have an iterator, right? Like something that can act as a variable for each of these numbers, but twice. So we need to create let's call it the first num variable. Okay, this first num variable is going to give us access to, like we talked about, each individual item in the list or array. And then as we go deeper into the nested for loop, we're going to create another variable that's going to temporarily hold the value for the second number, we'll call it, and that's going to give us the access to the other variable for each individual first number, right? First number. Okay, so step 4, we're going to create an inner for loop, and that's going to go right inside of that outer for loop. Hence, it's called a nested for loop, right? Nested for loop, right? Right? Okay. All right. And then step 5 here, we need to create another variable. It's going to be called second num. And that is going to represent each of the numbers being iterated over for a specific first num. Right? So we get access to each number twice within the same list because we're using the nested for loop approach. Okay, and then lastly, we need to return. Well, actually, sorry. A little spoke too soon there. Sorry about that. I was hungry, saw the food, started eating. Shouldn't have done that. Should have prayed first. My bad, my bad. Okay, so step 6, we need to evaluate whether or not first num plus second num equals target sum. Why? Because that's the whole premise of the problem. Right? We're looking for two numbers. They're going to add up and equal that number. And if you don't find any, return that empty array right there, the empty list. But if you do, slap that pair of numbers right on in there. You know? All right, so that's step 6 there. Okay? And then step 7. I guess we can call it 7a. So if, stand over here, I think it'd be easier for me to write. If true, right, and we're referring back down here to step 6, so we're evaluating whether or not first num plus second num equals target sum. If it's true, what are we going to do? We're going to return those two numbers. We're going to return first num and second num in an array. Right? Return first num and second num in an array like that. And then, yeah, I guess if we wanted to, we could write an else statement for 7b. We don't have to, though. The if statement kind of implies that nothing will be returned if it doesn't fall within those conditions. Step 8. We do need to return something, though. Like we talked about before, it's either got to be a pair of numbers from the list / array or an empty array. So that's what we're going to do in step 8. We're going to return an empty array if the for loop goes all the way through. Sorry, if both nested for loops iterate through the entire list and there's not two numbers in there that add up to the target sum, we're going to return this empty array / list. All right, so let's go over these steps again. We're going to create a function, takes in 2 parameters. It's going to take in an array or a list, and it's also going to take in an integer. And the integer is going to represent the target sum that two numbers from that array need to add up to. Okay. Second step, we're going to create an outer for loop, and then within that outer for loop, we're going to create another for loop. So I have a nested for loop with that situation is kind of slow, right? In terms of runtime complexity. We're talking like O of n squared, which is not optimal, but it's great for a first pass solution, just to get on the board, right? I mean, like you can't go for a 3-pointer unless you can, I mean, get a few layups in first, you know? Get a few spin moves, you know, get some layups, get your juices going first, you know, then you come back around, and then you can jab step, you can fade away, you can hit the 3 after that, Steph Curry with the shot boy. But back to this here, yes, sorry. After we create the outer for loop, we're going to create a first num variable, which is going to hold that value of, I guess it would hold the first instance of that number that we want to grab onto, right? And then, then we need to create an inner for loop, and that's going to give us another opportunity to hold that number, hold that specific item, or the value of that item, to be able to compare it to other items in the list. And then, talk about creating the second for loop, or the inner for loop. That's what's going to allow us to pass through that twice, and be able to have access to the same numbers multiple times. And then lastly, not lastly, I was just joking, step 6, we're going to evaluate whether or not first num and second num, when summed up together, whether or not they equal the target sum. Because if they do, we solve the problem, return that bad boy in an array/list, no particular order because they don't mention that, but I would clarify that with my interviewer and say, excuse me miss, what's your name? No, excuse me miss, do these have to be returned in a particular order? If so, like what kind of order? Ascending order, descending order, what have you? I can do it, whatever your problem is, I can solve it. And then lastly, we're going to return an empty array if no two numbers inside of this list add up to the target sum. All right, so we just finished the understand phase, we just finished the plan phase, now we're going to go to the execute phase, and then we'll reflect and refactor. We'll refactor in another video, but all right, so let's see here. We're going to erase our steps. I have it memorized, lucky for you. Alright, so like we talked about, that first step, right, is going to be creating a function that takes in 2 parameters. So let's call it 2 number sum. And we said it's going to take in 2 parameters. It's going to take in an array. And I forgot, I did mention that we're going to be using Python to solve the 2 number sum problem here. So actually this parameter, instead of being an array, it's going to be a list, right? So let's call it list. And that's also going to take in a second parameter of a target sum. So we're just going to put target sum like that. Pardon my sloppy writing. There we go. Okay. Slowly getting our function laid out here. Alright, next thing we need to do is we need to create that outer for loop, right? So outer for loop, so let's go for I in range. Now remember the range method in Python, it takes in 2 parameters usually. You don't have to, you don't actually have to put in the first parameter. It's kind of implied if you don't put it in that it'll start at 0. So, but essentially like the range method in Python, you need to put in a start and a stop position for whatever list it is that you are iterating through. And the trick thing here though is that with the range method, you need to be aware of the fact that the start parameter that you're putting in, it's inclusive, so it includes the 0th index. Right, if you're doing zero-based indexing, and then the stop position or the stop parameter, which is the second parameter of the range method, it is exclusive, so it will not be included in the iterated over items there. Okay, so we need to pass in. We're actually just going to pass in just the second one, right? So we're going to do range of length of the list, and we're going to subtract 1. Now, I know you're probably saying, Teak, how are we going to subtract 1 off of that, right? Well, put it like this. That nested for loop, it's relative. It will always be relative to the outer for loops iterator. So the iterator here we have is I. That's in the outer for loop. Remember, I is going to go it's going to go to the 0th item, the first index, second index, third index, fourth, fifth, sixth, 7th, right? Because there's 8 items in there. That's correct. The inner for loop, we're going to use J to be the iterator. That's going to be in relation to where I is. It's always going to be 1 in front, right? So if you make it to the end of the array, let's say I is right here. This has to be J. You can't make I go here, because if I goes here, then where's J going to go? Out here? Oh, that doesn't work, right? You're going to get an error that says outside of listed indices. And we don't want that. We don't want that error. Okay, so we've created our first outer for loop. Now we need to declare a variable that we talked about. It's going to be called first num. It's going to give us it's going to give us access to that each item in the list the first time. So we use the access. Okay, so let's call it first num, and we're just going to set it equal to list at the index of I. I hope you can see that. Sorry, I wrote it kind of small. All right, so first num is the value of the list at the index of I, which is going to be iterating right through there. And then this is where we have step, I believe it's 3, actually step 4, right? Step 4, we need to create a nested for loop. This is where we talked about we're going to be using J as the iterator now instead of I. So we have 2 variables that allow us to access each item twice for comparison purposes. So for J in range, okay, and then like we talked about before, range is a method in Python that takes in usually 2 parameters, but you can put in just the second one if you want. The other one can be implied. Okay, so, and we talked about earlier how J is always going to be relative to I, where I is at. So it's just going to be I plus 1, right? Because we want it to go in front. So if I is here, J is here. If I is here, J is going to be here. If I is right here, then J is going to be right there. You know? Like I and J, they're like best buds. They're always right next to each other. Like peanut butter and jelly. Or if you've ever seen Big Daddy, like lamb and tuna fish. Okay, so, sorry for that reference. My mind kind of wanders. Okay, so the other parameter in the range method that we're going to be putting in here is going to be the length of the list. Alright, and I know what you're thinking. You're probably thinking, Tico, come on, man. Like, why did you subtract 1 from the length of the list up here, but not down here? Well, like we talked about earlier, I is always going to stop short of the end of the list. Why? Because its partner, best friend, Batman and Robin's got to take that last position, right? So if Batman comes in, aka I, into that last position, yo, Jay is out here in the cold, in the rain. He's all alone. You're not going to do that to your boy, right? So you got to accommodate for that, okay? So that's why you get the -1 there, okay? And then his boy, Robin, is going to be able to make it to the end of the array and be able to sit on that last position without being outside in the rain, outside of the brackets, in the cold. It's cold out here, man. All right? Okay, so we got step 5 now. Step 5, we need to create another variable that's going to give us access to each individual items more than once. That's going to be second num. Second num. And that's going to be equal to the list at the index of J. I hope you can read that. Is that too small? Hope you can read that. Second num is equal to the value of the list at the index of J. Right? And remember that J is always relative to where I is at. Okay. And I believe the next step is evaluating. Now we have access to both of these variables because we're inside of the inner for loop. Here's what we do next. We'll create a little if statement. If first num plus second num double equals non-strict equals target sum. Then do the following. Well, what are we going to do if there's two numbers in here? That's sum of the target sum. We're going to return that bad boy, or both those bad boys. Oh, what you gonna do? Oh, what you gonna do when we return you? All right, so we're gonna return those bad boys. Ouch, that was my shin. We're gonna return in an array first num, comma. Actually, accidentally put a uppercase there. Second num, just like that. And we did mention earlier that we don't need an if statement because it's automatically implied that if it doesn't meet these conditions here, we're just going to skip over it, right? Just going to skip over the iteration. We do need to do one more thing, and that is basically handle the case in which there's no two numbers in this list to add up to the target sum. So what we're going to do, we're just going to use a little return statement here, line it up with this first for loop, and we're going to return an empty array. There you go, ladies and gentlemen. That's the brute force solution. We just finished step UPER. We just finished the E step, which is the execute step, right? We just executed our plan. Now we need to talk about like what we did. We need to reflect. That's the R in Ooper. We need to reflect. We need to refactor. I'm going to save the refactor for the next video, where we go over the optimal solution for two-number sum, and also another alternate solution that uses sorting and uses pointers. But for this video, we're just going to focus on the brute force solution, which is a nested for loops. And if we talk about reflecting, and we talk about time complexity, the time complexity for this, because we have nested for loops, is going to be O of n squared. Right? So O of n squared, it's going to take a long time, because I mean, you got to go through each one of these items in the list multiple times, right? And for each item, you're going to be going through every single other item. So that's where the squared comes into play. And then we're going to also talk about space complexity. What is space complexity? Space complexity, well, if you can think of time complexity as what happens to the number of operations your algorithm or function is going to perform as n gets really, really close to infinity, or some arbitrarily large number, right? We're going to look at how fast the algorithm runs. So as n increases here, the number of operations we're going to be running also is going to increase at a substantial rate there, right? So that's why it's very, very poor algorithm in terms of runtime complexity. But space, instead of looking at the number of operations that your algorithm needs to run as n increases, the input increases, and here we have two inputs, we're going to be looking at any auxiliary memory that your algorithm or function will require in order to run. So that would be something we'll look at in the next video. The space complexity for this particular solution, the brute force solution, is actually just O of 1, right? Reason being is because we don't need anything other than the memory required. That's the memory that's given to us in the inputs there. We don't require anything more than just that. Now, if we were to create an object or a dictionary, right, for memoization and caching, which we're going to be going over in the next video, then yes, it would not be O of 1 space complexity. It'd be O of n space complexity, depending on our algorithm. But yeah, it would be higher than that. And in a situation where you value space, Maybe you would look at something like an algorithm that uses sorting to sort these numbers first. And then it would use pointers, right? That would slowly move inwards until it found a pair of numbers that added up to the sum. And that would be more optimal than this brute force solution, but less optimal than the memoization solution, which would be there'd be O of n runtime complexity and O of n space complexity. Whereas the sorting and the pointers solution, because that uses sorting, I believe that is going to yield runtime complexity of O of n log n, and also it's going to have a space complexity of O of 1. So actually the time complexity improves on that solution. Space complexity remains O of 1, which is great, right? We're not creating anything outside of the memory that we need for the given inputs. So yeah, that's the whole thing. That's the whole shebang. That's all she wrote. So thanks for watching. Love your feedback and comments and critiques on how I can improve my delivery. Maybe include less dancing, less jokes. I realize that. I can't help it. I enjoy having fun at the whiteboard. I gotta make this fun. It's gonna be a career soon. So thanks again for watching, and see you in the next video.